Today we're going to talk about function notation. I am sure that you've seen an equation written like this. We know that x is the input and y is the output. We could also write the equation like this, where we have f of x is equal to 2x. Now this f of x doesn't mean f times x, but we say that it is f is a function of x, or f of x. And here, x is the input, and f of x is the output. This is what we would consider function notation. And we can see that since y is equal to 2x and f of x is equal to 2x, that f of x is equal to y. They are both outputs. So that was always an enlightening thing to me when I was taking algebra, when I realized that f of x and y were both outputs. Let's take a look at f of x equals 2x. Let's evaluate the function when x is equal to 1. To do this, we would write f of 1, because 1 is going to be our input, and then we would substitute 1 in wherever we see an x. And we would say 2 times 1 is 2. So f of 1 is equal to 2. So for this function, when the input is 1, the output is 2. Let's take a look at another function. Let's evaluate this when x is equal to negative 3. Again, we're showing that f of negative 3, that's our input, so we're going to substitute in negative 3 wherever we see an x. Then we know that 4 times negative 3 is negative 12, minus 2 would be negative 14. So this tells us for this function, when the input is negative 3, the output is going to be 14. So what if I'm given the output and I need to solve for the input? So let's take the function f of x is equal to 3x plus 4. We want to solve for x when f of x is equal to 19. So here we would substitute 19 in for where we see f of x in the function. So I'm going to write 19 is equal to 3x plus 4. And then I would want to solve for x. So to do that, I want to subtract a 4 from both sides of the equal sign. So I'll get 15 equals 3x. And then again, to get x all by itself, I would need to divide both sides by 3. So I would get 5 is equal to x. That seems a little bit funny to us to write it that way, so you can go ahead and write it as x is equal to 5. So this means f of 5 is equal to 19. When the input is 5, the output is 19. So now, go ahead and write this function down and evaluate it for negative 6. I would encourage you to pause the video now and do this. Now, for the function, solve for x when f of x is equal to negative 17. Again, pause the video until you have done this. Now let's check your work. To evaluate f of x is equal to negative 2x plus 3 when x is negative 6, we would want to substitute in negative 6 wherever we see x. And then we have negative 2 times negative 6 is 12 plus 3. So we get f of negative 6 is equal to 15. This means when the input is -6, the output is 15. Let's check the next one. For the function f of x is equal to -2x plus 3, we want to solve for x when f of x is equal to -17. So again, I'm going to substitute in -17 for where I see f of x in the function. So I have -17 is equal to -2x plus 3. To solve for x, I want to subtract 3 from both sides. So then I'll have -20 is equal to -2x. And then divide both sides by a -2. So I get 10 is equal to x. Again, we can write that as x is equal to 10. But what that means is when the output is -17, the input is 10. Now let's look at an application. So let's say we're given that the notation P of T represents the pressure of a certain gas in psi at T degrees, and our temperature is going to be measured in Celsius. Interpret the meaning of P of 80 equal to 24. First, we would need to identify what's our independent and what's our dependent variables. So here, the independent variable, or the input, is temperature. The dependent variable, or the output, is pressure. So we would interpret this by saying when the temperature is 80 degrees Celsius, the pressure of the gas is 24 psi. Let's look at one more. The notation d of t represents the distance in miles a person traveled after t hours. Interpret the meaning of d of 2.5 equals 125. Again, if we look and see what the independent variable is, we could say, okay, the independent variable, or the input, is time. The dependent variable, or the output, is the distance traveled. And we would interpret this by saying after 2.5 hours, the person has traveled 125 miles. So hopefully through this video, you know how to write a function in function notation, how to evaluate a function when given an input, solve for the input when you're given the output, and given a situation, be able to interpret the information written in function notation.